Using the message instruction. Message read or write. There really is only one message instruction, and it can be set up as a read or a write. The message instructions, read and write, are used to directly read from or write to another PLC's data table without its consent or knowledge. Although these instructions use the communication ports on the controllers, they do not facilitate communications in the conventional sense. But it is a method for sharing data between processors and data tables. When humans communicate, we have a thought, and if somebody's nearby, we might communicate our thoughts. PLCs don't communicate thoughts, but they can share data from their data tables. With some additional logic to verify data transfer, it can approach something more considered communications. Your logic knows what is going on, in a way, but not the controller. The controller has no idea what's going on. But whoever wrote the logic has a sense of what they want and what they know when they're writing the logic. But the PLC does not think. The controllers that you are using with this training manual will determine whether or not you can exercise the message instructions. If you are using a MicroLogix 1000, it is possible to connect directly to another MicroLogix 1000, but it's very difficult. There are hundreds of possible combinations of processors, cables, COM ports, and drivers. For that reason, addressing all of them is totally outside the scope of this training manual. An example of the configuration of a read and a write instruction for a MicroLogix 1000 is included on the following pages, and a more elaborate example using Ethernet with RSLogix500 processors. These instructions were included in your manual. They give you specific direction for communicating between two MicroLogix 1000 controllers. But you cannot do it without the use of an AIC plus interface converter. Also, you have to pay attention to whether they are Series C or earlier, Series D or earlier controllers. And be careful to note that both processors need to be powered by the same power supply. We have delivered this lab project many times in classrooms with excellent results. What you see in front of you are 7 RSLogix500 of the 505 variety, the Ethernet processor. You also have 7 laptops. You also have 7 switches or hubs. Hubs have become so inexpensive that switches are a preferable device as opposed to a hub. It is not the intent of this instruction manual to train you on Ethernet. So let's just consider Ethernet a network protocol. Everybody on a network has to have an address. I don't show the addresses here for the laptops, but all 7 of these PLCs and all 7 of these laptops are all on the same subnet, which means all 14 of these devices will have an IP address that will begin with 100.100.100. The processors themselves are the 505s, RSLogix505s, are 100, 100, 100, 101, 102, 103, 104, 105, 106, and 107. Whereas the laptops can be any of the other IP addresses available that aren't already used, 101 through 107. More than likely, that first laptop, number 1, is going to be either 1 or 11. If the first laptop is 11, the second one is 12, 13, 14, 15, 16, 17. The reason for doing it that way is to keep very logical control on the assigned addresses in this network. Now let's look closer at one of the processors. I say processor, but really I'm only showing you data table registers for each of the processors. So let's start with the first one, the processor that has an IP address of .101. In bright blue we have N70. In green we have N71 through N77. In lighter blue we have N27:0, and then in orange we have N37. If you look at the top of the screen, the color indicates the functionality. So N70 is data that is written out from the processor through message write instructions. In green is data written to you from the other processors with message write instructions. The cyan or pale blue is data that you generate to be read by all of the other processors. And orange, those locations are where you store data that you have read in from all the other processors. So you typically would be laptop number 1 and processor 101. And everybody else is 102, 103, 104, 105, 106, and 107. When you actually open up RSLinks, if you've included everybody, you can see all 7 laptops and all 7 processors and their IP addresses. We are not concerned with Ethernet and explaining Ethernet in this lab, only the instructions. The message instruction, set up to read or set up to write. Let's take a closer look. N70, the source memory location written to all other stations. I am station 1. The data in N70 is data that I want written to all the other stations, but I write it to a location at each of these other stations that they know it's from station 1. For instance, if you look at the areas that are grayed out, station 2, 3, 4, 5, 6, and 7, notice that N71 is grayed out on station 1. N72 is grayed out on station 2, N73 on station 3, etc. The data in N70 from station 1 is written to N71 in station 2, station 3, 4, 5, 6, and 7, which means that the program in each of these other stations recognizes N71 as data written to them. You see up above in green it says data written to you. And this is all from the perspective of you being one of these processors. So obviously I wouldn't write N70 to N71 in my own processor, but I would write N70, the value in the register N70. I would use a message write instruction and send it out to N71 and all of the other processors on the network. This is data that I want them to know. I want to keep them updated, and it would be data that's relative to station 1. Station 1 obviously doesn't write data to its own station number. So you see, as I said before, N7 : station number is not used by that station number. So station 5 would not write data to N75. Station 6 not to N76. Station 7 would not write data to N77. Now, because I'm station 1, station 2 is going to write data into my N7.2. Station 3 will write data into my N7.3. So if in my program, and of course I don't care about N7.0 because I'm the one that created that data, and I updated everybody else on the network with the value in register N7.0. But N7.2 through N7.7 are register values that were written to me, to these locations from all these other stations. It's data that I would not know unless they updated me with it. So you see, data written to you is in green, and you don't write information yourself, so your station number for a word number in the file N7 is always grayed out and not being used. N27.0 is data that I want to share with all the other stations, but the major difference between N7:0 at the top and N27:0 is that N27:0 is not data that I write to the other stations. It is data that they can come and read if they want it. I am not going to read my own data and put it in N37.1. Neither is station 2 or station 3 or 4 or 5 or 6 going to read their own value in N27:0 and store it in their own station number. So just like the upper group, data written to you, data you read in, you don't read your own data in. You already know what that data is. So N37:2 in my processor is data that was read by station 2 from station 1. N7.0, data that station 1 wants the other stations to have immediately, so it will write those out to their green addresses. See, green, data written to you. The green addresses, data that station 2 wants station 1 to have immediately, data that station 3 wants station 1 to have immediately, and so on. N27.0 is data that station 1 makes available to anyone that wants to read it. And then data that station 1 read from station 2, data that station 1 read from station 3 at its leisure. What you see here and what you saw in your lab book is slightly different. In the lab book, we actually showed you how to hook up or how to configure these read and write instructions for Ethernet. Here we've simplified it. We just show local node address by the station number rather than the full setup pop-up box that you would see for Ethernet. So in this case, you see this controller, data table address N70, so your station 1, size and elements 1, target device, data table address N71, station 2. So N70, that's this controller. N70, data you write out is going to go to station 1, data written to you. Station 1, is going to go to station 2. The data table address is N71, And Station 2 knows that N71 is data that was written to it from Station 1. And of course N72 is grayed out on Station 2 because Station 2 doesn't write data to itself. For local node address 3, which would be Station 3, again, this controller, the data table address that we're going to write is N70 size and element 1, and we're going to write it to N71 Station 3. So all of these write instructions are going to write N70 from this controller, N70, to N71 in all of the other Station 6. In other words, we're in the Station 6 program now. We open up the dialog box. This controller, which is Station 6, N70 size and elements 1, we're going to write it to N76 in Station 1 and Station 2 and Station. Now we're doing a read instruction. It's still a message instruction, but it's set up for a read. And we want to read into our controller. So this controller, the data table address, would be the address or the memory location into which we want to read from the target device. So N37:2, and we are Station 5. And the target device is Station 2. So we're going to read N27:0 and store it in this controller, N37:2. So if Station 3 needs to update Station 7, Station 3 moves the data into N70. Executes a message instruction with a target of N73 node number 7. That's how Station 3 updates Station 7 with the data that it wants Station 7 to have. If Station 5 needs to get an update from Station 2 on its own, unsolicited, Station 5 executes a message instruction reading into N37:2 from a target of N27:0 at node 2. That concludes the narration of the Advanced II Lab Project book. I hope you had an excellent educational experience. And I thank you that you have stuck with me and endured any background noise, any grammatical errors, any fumbling with my lips. I found that if I do this with a script, even though I've written out everything I want to say, it sounds choppy and red. If I make a mistake and go back and re-record it, then that mistake is gone, and almost without exception put in another mistake. So I no longer use scripts. I look at the slides that I've created, and I relate what I remembered from when I had a live audience. So thank you from the PLC Professor. You can view our entire product line on the PLC Professor website. Thank you and have a good day.